So usually when we are handling the text data, we define the model, we give the input layer, and then we give this Word2Vec layer. That means in the input layer, you take the text data. In the Word2Vec layer, you convert them into vectors, and then the rest of the layers will happen automatically. That is it. That is the only purpose of having our Word2Vec. But if that is a usual way of using in the deep learning algorithms, but we will do it if we are converting manually on our own, and if we want to see these vectors, if we want to draw graphs like this, which we may not need to later on. How do you do that Word2Vec? Let us check. We will take this data only. Later on, we'll take some other data set. Okay. So king is a strong man, queen is a woman, etc., etc. We will take this corpus. We will simply clean this corpus. Very simple cleaning. E is a, etc., etc. These stop words we will remove. Some other commas, full stops can also be removed. Fairly clean data. We just need to remove the stop words. Okay. What we are going to do now is we are going to convert these corpus, all the words in this corpus, into vectors or into numbers. In simple words, we're going to convert these words into numbers, but what are we going to do? We're going to preserve the context. These words are related to each other. That is how we are going to convert them. Let us go to the code file and then work on it. Get required packages. Okay. Give the corpus. Let me give the corpus here. Clean the corpus by removing stop words. Remove the stop words. I don't think we need to write this much big of code. We can simply use remove stop words. And then this is the corpus, new corpus, which is kind of pretty clean. These are all your words. All the words, distinct words are these one. Okay. Till now, if we have these many distinct words, we do one hot encoding or document term matrix or something. But here we are going to do a different method. Okay. You have these words, you have the sentences. Now let us prepare the data. Here I'm taking the window size as 2. Look at this, all of you, carefully. What is window size? What do you mean by window size? Which window size is this? Tell me. Which window size? There is a technical word for this window. Which window is this? Context window size, this one. The context window size is 2. That means around every word, I will look for 2 this side, 2 this side. Let us suppose this is A will be anywhere removed. So this is one word, then 2 words will be this side, 2 words will be this side. That is the meaning of window size 2. Okay. Here, so this is a small data set. That is why I'm taking window size 2. Usually the general suggested value is you can get the context by browsing through 10 words. That means previously 5 words, later on 5 words. Maybe give a window size between 5 to 10. That should work. All of you with me? Context window size 5 to 10 is sufficient. Are you with me, everyone? 5 words this side, 5 words that side is sufficient. So this is the context window size. Here is the data where I have the input. What is the output label? What is the output? Input is window, output is context. Word. So king is in the context of strong, king is in the context of man, strong is in the context of king, man, etc., etc. It's exactly the similar way that we have discussed. Input word and the output context. Okay, this is the dataset shape, doesn't matter. Now we have to build the model here. This should be input, this should be output. How do you build the model? You have to convert them to one hot encoding, etc., while building the model. So convert them to one hot encoding for the process, for the purpose of model building, but these one hot encoded values will not be used at the end. So converted them to one hot encoding. What do you mean by one hot encoding? If you have 12 different words, that means you are going to create 12 columns. That is what 12 columns are created, and you have 42 rows here, 0 to 41, and then one column will now be converted to 12 columns. Later, model building. Now all of you need to understand this model building. Look at this carefully. Model equal to sequential. We are back to Keras. Model dot add dense 3 comma input dim activation. Can somebody explain me these parameters one by one? Can you tell me what is 3? This is an ANN model. Dense, what is 3 here? In this hidden layer, there are 3 nodes. Input, yes, hidden layer with 3 nodes, that's right. Manas is correct. And then input dim, I have to give input number of dimensions. 12 will be the answer. Even if you check this out, it will be what? 12 only, doesn't it? Even if you check this out, my x number of variables are 12, comma, how many number of rows, doesn't matter. Activation is sigmoid. That's it. We had to build a shallow neural network only here. Output, number of output nodes, and then activation is softmax. That's it. Model will be built. This is model configuration. Later model will be built. Configure the model will be built, but I'm not interested in anything else. I'm not even interested in the model results. All that I'm interested is that intermediate hidden layer output. That is my representation. That hidden layer output that you're going to get three values for each of the word. That is what I'm interested in. So once the model is built, it's still building. Let it build. 500, 600 epochs we give. It doesn't matter. Whatever is the accuracy, you don't need to worry about it, because there is no decisive way we have mapped everything to the correct numbers and all that. Whatever is the accuracy, we want to somehow map these words into context. You may get less accuracy, but you don't need to worry about that. But what are you really interested in? I'm interested in the hidden layer output. How do you get the hidden layer output? Model 1.h is sequential, whatever you have added. And then you are giving these input vectors. First you will give king. Then you will get the hidden output. Model.add activation sigmoid without output layer. I am just dealing with hidden layer only here. So I will take the previous model, I'll take the hidden layer output, I'll give my data set, and I'll get the vectors here. These are the words, these are the vectors. King has been represented like this, strong has been represented like this. Remember, a single neural network can give different values. So your king might be having a different vector, your strong might be different vectors, your queen might be different vector. It doesn't matter, because those vectors are consistent based on the data that we have. That means king, you may have different values, queen, you may have different values, but they will be different. King and strong will be obviously in the same context. Now here is a visualization of the data. So here is the original data frame. Finally, 3 values. You don't need to always visualize it, but for better understanding, this is how my data is. As I told you, the third dimension is difficult to visualize. That's why not always it is very easy to see that 3 are formed. Okay, princess and woman are very nearby. Wise, queen, girl, the kind of these are coming in one place. King, strong, man, prince, these are coming in one place. Boy, pretty, young, girl, these are coming at one place. For you, this may be a slightly different visualization, but it will be consistent. Okay, if it is not very clear for you, what you can do is you can rerun this model once again. Not a problem at all. Rerun that model, re-execute this, you will get new weights, new representation. Then you'll be able to see new graph, slightly different values, but it will be consistent. All of you quickly execute this. Once you have this graph visualization, let me know. So we have manually built it. In reality, we don't need to do that. Just for understanding how it works, we have built it, and we may not be able to draw the graphs as well. Okay, the story till now is we understood words has been converted to vectors, and while we are converting them to vectors, the relationship is also preserved. Here we took word as input and context as output. Hey, why can't I take context as input, word as output? Can we try that? Yes, we can actually take context as input, word as output. Instead of saying this word is in this context, we can also, this context is connected to this word. Both the methods are accepted. One method is known as skip-gram method. The other one is CBOW method, continuous bag of words. Okay, word to context. If you take word, the one that we have tried right now, word as input, context as output, this is known as skip-gram model. The other method is very similar to this, but context is here, word is here. That is also can be tried, known as continuous bag of words. Skip-gram is the one that is most widely used. On a small data set, both of them give the same results, but a lot of people try skip-gram. Go back, see continuous bag of words on a different problem. Some people have proved that this is slightly faster compared to skip-gram method. But for us, we will not see a huge difference. We will go ahead with skip-gram method. Now, do we really need to write this much amount of code every time when we are converting word to vectors? Is there any package that can take care of it automatically? Yes, there is a package called GenSim. GenSim, there is only one line of code that you write, then you are through. From GenSim models, import Word2Vec, give your corpus. Minimum count is like how many times the word has appeared. It has to appear minimum number of times. Otherwise, you ignore that word. That means if you say minimum count is 1, even the word appeared once, then you will go ahead. If you say minimum count is 5, that means there is a particular word that has appeared only thrice, then that will not be considered. Okay. So minimum count. But two important parameters that you have to give: size equal to 3, words equal to 2. Can somebody tell me what is size, what is window? Window equal to 2. First, let us talk about window. Which window is it they're talking about? Window is the context window size. Size is the number of hidden nodes in that hidden layer. Hidden layer is the size. Window is the context window. That is it. Then from the GenSim output also we will get similar results. If you say model.most similar, what are the words that are similar to man and queen? Negative is woman. That means you remove woman, which are similar to man and queen. Then it will say strong is coming in that context. That means it is as similar to saying as man plus queen plus minus woman. If you do like that, what will be the result? The result will be very similar to strong. Result will be very similar to king, is what it is saying. Remember, Word2Vec is one of these strong technique that is right now available. You will be surprised or to see the results later on. Okay, as of now, let us do the same thing once again using GenSim model. Okay, earlier we wrote it manually. You don't need to do that in reality. You can use GenSim. In fact, you don't even need GenSim later on. There is another method that I'll tell you, which is even easier. Get the data set, which is our king, queen data, and then give the input. Okay, these are the documents. King is a strong man, queen is a wise woman, etc., etc. And then mention these three parameters. I have given the explanation of these three parameters. Size is the hidden node size. Window is the window of the context window. Okay, size of the context window. Minimum count, you can skip this, not required, but size is required. Window size is also required, context window size. Then you can get the vectors like the way that we got earlier, automatically built by GenSim. You can also print specific vectors. These are the results. You can save the model. You can give this model to somebody else. Somebody using the same corpus can use your model. Listen to this carefully, all of you. You have built this, you have converted them to numbers. If somebody has the same corpus, if he doesn't have different words and all that, he can use your model, he can load your model and then get these results. So if there is somebody who has already trained a model, pre-trained a model, can we use his model? Yes, we can use his model and get the results based on that model. That is how it works in GenSim. Any questions on this? The results, actual paper, in the actual paper, if you see, they have given like really beautiful results. They have told that if you give France and Paris, and then you just give Italy, if you do not mention anything here, automatically it will be predicted as Rome. If you say France to Paris, how is Japan? And if you say blank, Tokyo will be predicted here. Okay. In a particular corpus, they have trained on this chemical elements and all that. Copper, Cu, zinc, that's what they gave. Result was given as Zn, the most similar result. Okay. Gold when they told Au. Okay. Microsoft Windows they told, then they told Google. The result was predicted as Android. IBM, Linux was predicted. Apple, iPhone was predicted. It all depends on the input data, obviously, but the relations are preserved, you know, very effectively. Now there is one pre-trained model that you can use, which is given by Google, has pre-trained on news around 300 million words, I think. Huge data set. They have trained on a huge data set, and then they have given each word. For that word, they have given the representation, numerical representation. We don't need to even build the model. We will directly take this model from Google, which is in this bin format, okay, binary file. Load the model, simple. You just load the model, then directly use it. Earlier we used to define the model, etc., etc., everything we used to do. Simply you take the file name Google model, and then model equal to keyword vectors dot load Word2Vec format. You give the file name, binary type is true. This is a binary model. Model has been stored in binary format. Then here are the results. If you say positives are Delhi and China, negative is India. If you give Delhi and China, basically you said Delhi plus China minus India. If you remove Indian factor from there, what will be the result? The results are Beijing, Shanghai, or Beijing, like different formula. If you just simply say polite, what are the most similar words? It says courteous, and these are respectful, mannerly. These are some of the similar words. So go ahead, get this pre-trained Google model. We will try to test it, like we will give different words and check whether how well they have trained. It is supposed to be one of a very good model that is available right now that can be used directly. Let us go here. Pre-trained Google model. First you give Google authentication and all that, everything that is required. Get the trained model. It's a very huge data set. It may take a couple of minutes for you to load. It's a 3 GB model. Remember, data is not 3 GB, model is 3 GB. That means after building the model, they have considered those many factors. That's why this is 3 GB model. It will take a couple of seconds, maybe a minute or so for loading it. You can do it along with me, and then once you have this file loaded, give me a notification. So it is still loading. So what we are trying to do here is we're trying to get this file, store it in our local environment. Right now it is still downloading. If everything works well, this will be a 3 GB file, nearly 3 or 2 GB file, still downloading. Okay. It is still downloading. After that, what are we going to do? Once we have this is the file name. You just load the models. Okay. So I think we are done with that. Now what am I going to do is load my model. That binary file will be loaded. Once the model is loaded, I'm going to check Congress Sonia. I have given it. What are the most similar words to Congress, Sonia? This is a news data based on your news, based on all those things. Give me the words that are in the context of Congress and Sonia. Okay. Then it will go through it and it will tell us the words that are very similar to Congress and Sonia are these. Okay. What are the words that are very similar to polite? That can also be asked. Okay. So the result happens to be, let us wait. Manmohan Singh, Sonia Gandhi is in the context of Congress. Manmohan. BJP is also in the context of Congress. Nitish, Gandhi, Parliament, Kalmadi. Kalmadi has to be there. This is in during that time. Data it is. Nehru dynasty, etc., etc. Check the power. Polite, if you say what are the similar words, these are the ones. France, if you say what are the similar words, these are the ones. India, if you say what are the similar words, in the context, in India context, what are the similar words? Indian, USA, Pakistan, Chennai, America, Sri Lanka, etc. Dhoni, what are the similar words? Sehwag, Sachin. This is slightly outdated data. I don't think Kohli was there during that time. Even if you give Virat or Kohli, it might throw an error saying our news articles don't have it. It's slightly outdated data, 2009 or during that time when Kohli was not there, 2013 or something like that. Similarity between two words also can be checked. Dirty and smelly has high similarity. Dirty and great will be having low similarity. Dirty and ugly will have even higher similarity. Okay. What about three words that you gave? Run, walk, France. Which one doesn't match? Basically, you will find the similarity, and the one that is least similar will be the one that doesn't match. France is the one. Run, walk, and France. France is the one that doesn't match the context. But if you say run, India, France, now run will be the one that doesn't match the context. And one of the naughty students has tried it to test it whether this really works or not. He has given Nityananda. Okay, what is the context of Nityananda, and tell me whether yeah, this was not tried by me. Okay, somebody has tried it in the uh, classroom, but I found it funny and good. But it shows the power. If you give Nityananda, what are the things that are in his context? You will get Nityananda, God man, Swami Nityananda, and yeah, obviously the ones that are in his context. Yeah, and then chess, if you give it, yeah, maybe if we increase instead of top 6, if I put top 10, maybe I'll get the scam also and all this. Yeah, Asaram Bapu, Tamil actors Ranjita, etc., etc., and all. So basically, this is a pre-trained model. Usually, we don't use Word2Vec like this. We will put Word2Vec or word embeddings as one of the layers. But behind that one single line, this much work will be done. So in future, we will be using this in several models, but there we will simply mention this is the Word2Vec, basically the thing that we have mentioned in GenSim. So this line here will be word embeddings model.add word embeddings layer, and then input shape will be from the previous one, and we'll just give the size of the number of hidden nodes and all that. That's it. That will be simple line that we will be using. Rest all will be done by the model itself. Okay. Yeah. Any questions on that?